Good morning, my name is Laisha Nino, and today we will be learning and discussing 6.1 Systems of Linear Equations. So we will be learning how to solve for the solution to system of two linear equations. For our first example, we will determine whether the ordered pair -2, 0 is a solution to the system of linear equations below. So the first step that we usually do is write down our x and y. So -2 is our x and 0 is our y. So what we're trying to find here is if these two equations are useful in being solutions to this ordered pair. So the first thing we're going to do is plug in the -2 into x. So it would be 8 times -2, put parentheses, minus 3 times 0, you plug in for y, equals 16. So we're going to do the math, and we use our calculator. 8 times -2, so that's -16 minus 3 times 0, 0 equals -16. So we can see here that -16 minus 0 equals -16, which is equal to -16. So that works as one of our solutions. Now we're going to do the same steps with the second 5, and then plug in -2 for x, and then plus 2, plug in 0 for y, equals -41. So we're going to do the same steps here in the calculator. 5 times -2 equals -10, plus 2 times 0 equals -41. And we can see here that -10 plus 0 equals -10, which is not equal to 41. This is a no. So then we can write down no, -2, 0 is not a solution to this system of equations. And there you go. Okay, so for example number 2, it says, find the solution to the system of linear equations below using elimination or substitution method. So for these two equations, I'm going to use the elimination method, and we want to see that they line up with each other, and these equations do. Now, what we're trying to do is find our x and our y. So we're just going to leave that off to the side. And we want to have a cancellation so it can equal 0. So what we're going to do here is we're going to multiply the bottom equation by -3. So then you would just rewrite this one the same. So it would be 3x minus 4y equals -31. And then this one you would do -3 times 1, which is -3x. And then plus -3 times 1, I mean your imaginary one, you can just, it's right there. It would be let's pretend that's not there. It would be -3, right? -3y. And then you would do -3 times 6 equals -18. So now we're going to add these two together. So, 3 plus -3 equals 0. So you don't have to write it down. And then -4 plus -3 equals -7y. And then -31 plus -18 equals -49. Now we're trying to get our variable y alone, so we're going to divide by -7. And -49 divided by -7 equals 7. So y 7. Now we write that here. Now to find x, we can use either this equation or this equation and plug in our y. So I'm going to use the top equation. So I'm going to put 3x minus 4, and where y was, we're going to put 7 equals negative 31. So now we're going to do the math. So negative 4 times 7 goes negative 28. And then just bring down everything else. So negative 31. Bring down 3x. Now here we're trying to get this variable alone. So we're going to add 28 to this side. Now 28 and 28, it cancels out. So you're left with 3x equals, and then you do negative 31 plus 28 equals negative 3. So then to get variable x, we're going to divide. So negative 3 divided by 3 equals negative 1. So x equals negative 1. So up here, x equals negative 1. And then we're going to circle that so we don't forget. This is for our y. This is for our x. Now you can leave them like that, or you can put them, or you can do negative 1, 7. So this is our solution right here. X solution. Okay, so for our third example, it says find a solution to the system of linear equations below using elimination or substitution method. For the third example, I'm going to be using a different method. I'm going to be using the substitution method. It's kind of like the first one, but it's just another method to try. So for this one, we're going to basically put in one of the equations inside of the other. So you can use either equation. I'm going to use 5x minus y equals 41 just because the y is by itself and it would be easier to solve for y. So I'm just going to rewrite it. 5x minus y equals 41. And then I'm going to take away, I'm going to subtract minus 5x. So it would be negative y equals 41 minus 5x. So now we know that negative y, 1, is equal to 41 minus 5x. We still don't know what y is, but we know this is what it equals. So what we can do is we can take this y value and plug it into the first equation. So we're going to rewrite the first equation, 7x plus 2, and where y was, we are going to put 41 minus 5x, parentheses, equals 71. Okay, so I'm going to rewrite this over here just so we can work it out. 7x plus 2, 41 minus 5x equals 71. So we're going to, of course, distribute. So 2 times 41, 82. And then 2 times negative 5, negative 10, just to check it. Negative 10x. And then we would just bring down the 7x equals 71. So now we're going to combine like terms. So 7 plus negative 10. So negative 3x plus 82 equals 71. I'm going to keep going to find our x. So we're going to subtract 82. That cancels out. Negative 3x equals 71 plus negative 82, negative 11. So then we can divide to figure out our x. And when we divide negative 11 divided by negative 3, we get a decimal. Decimal x equals 3.66. So this 3.66 solution. So now to figure out our y, we're going to put y is equal to 41 minus 5. And then where x was, we're going to put 3.66. So we do negative 5 times 3.66 equals negative 18.341 y. So negative, so it's like a negative 1 is there. And then 41 minus 18.3, it would be 22.7, negative 1y. So we're going to divide. It's just going to be the same thing, but just to make sure. So then y equals negative 22.7. That's our y. So both our solutions right here. So to complete it, our solution, if you want to write it like this, x and y, or you can put it together, negative 22.7, like that. Okay, so for our fourth problem, it says find the solution to the system of linear equations below using elimination or substitution method. For the last problem, I'm going to use elimination method just because I prefer that one. What we're trying to figure out here is we're trying to figure out x and y. So the first thing we're going to do is see if they line up, and they do. And now we check if there's any cancellations, and we see that there isn't, but it's okay because we can make them cancel out by multiplying one of the equations. So here, we're going to multiply the second equation. I'm going to go ahead and cancel out the y's. So do by negative 3. So then this one will just stay the same. So we do 9x plus 3y equals negative 7. And then this one we're going to distribute. So negative 3 times 3, which is negative 9. So we're going to negative 9x. And then negative 3 times 1 equals negative 3y. And then negative 3 times negative 4 should equal 12. So now that they're here, we're going to cancel them out to find the 0. So we're going to add these together. So when we add together, see 9 plus negative 9 is 0. So you don't have to write it down. And then, or you could just to have it, but 3 plus negative 3 is also 0. So we're left with negative 7 plus 12, 5. So since they're all both 0, this is a false statement because 0 doesn't equal 5. Everything canceled out, the x's and the y's both canceled out, so that is why this is a false statement. So what we know is that there is no solution to this problem. No solution. Okay, and that's the last problem.